Good evening. We're broadcasting from the Georgia Tech Observatory, which is on the roof of the Howey Physics Building in downtown Atlanta. This is our first ever online streaming public night. We had a public night scheduled for tonight, the last one of the academic year. The weather is gorgeous tonight, and it's a shame that due to public distancing measures, we're not able to have people physically here. So we're trying to do the next best thing. But this is also a test run for us, and us consists of John Wallum, who's operating all the controls, and I'm Jim Sowell. I'm the director of the observatory. But we do have a gorgeous night. We seem to have everything working well, and we're going to begin by looking at the planet Venus. Shift over. So this is what you're seeing on the screen is kind of a naked eye view. Venus is very bright. If you were to go outside right now for the next 3 weeks, that's about all you've got, and look to the west, and you can see it just a few minutes after the sun sets. Well, due to its orbit, it's inside the orbit of the Earth, and it's kind of like a track race, and Venus is about to overtake the Earth. So what we're seeing from the perspective of the Earth is the unilluminated, the non-illuminated side of Venus. So Venus goes through phases just like the moon. And I want to show you a zoomed in view now. You see that Venus looks like a crescent. Now this is not due to an eclipse like 2 years ago with the moon moving in front of Venus, but rather this is just an orientation effect. And during the next 3 to 4 weeks, Venus is going to get more and more in line with the Earth and the Sun. The crescent's going to get thinner and thinner, and in about 5 weeks, Venus is going to suddenly be a morning star. We're going to lose it from evening. Most of the time, Venus looks like a full moon or a crescent, but now is the time to really get to look at Venus. It's bright, and it's near to the Earth, so through a telescope or a pair of binoculars, it's actually quite large. You want to do some zooming or change anything? So now, unfortunately, the crescent shape is about all you're going to see. Venus is completely covered with a thick layer of clouds. We cannot see down to the surface, and so all we're seeing is reflected sunlight. And so really the phase is all we're going to get. In fact, it's so bright in the white light, if you do put a telescope on it, you might have difficulty focusing. It'll be red on one edge and blue on the other. By the way, this is one of the 2 major observations by Galileo that showed that everything needs to be going around the sun instead of orbiting around the Earth. He recognized that Venus would not go through phases like this if we were an Earth-centered cosmology, solar system, but instead we have to be going around the sun. So we need to spend a few minutes looking at Venus. I'll try to think of a few more things. What we're going to do in a minute is look at the moon in a few minutes. We got to see, John and I saw the moon rise about 20 minutes ago, but it's behind one of the tall Atlanta buildings, and so we're just waiting for it to poke out. And my guess is that's going to be maybe in 5 minutes, but as soon as we can see it, we will go over to the moon and we'll start looking at features. So again, Venus is the brightest object except for the moon out in the sky right now. If you're able to get a good view and a little bit darker view if you're not living in downtown Atlanta, there are some other bright objects out at the moment. Some of the winter constellations are over where Venus is, and you can see them. Sirius is the bright one to the lower left. Here we have Venus. We're highly zoomed in, and people ask about magnification. So magnification, when you increase it, also increases the bad. In this case, what we're doing is we're looking through a lot of atmosphere. It's the twinkling is what's causing this. There might be the heat from a few buildings also. But, if you were to do this every night for the next week, the crescent is going to get smaller and smaller. A few other characteristics about Venus. It's about 90% the mass of the Earth and about 90% the diameter. It does not have any moons. We have to use radar images to penetrate the clouds and see down to the surface. It looks like it has 2 large continents, whereas the Earth has about 7. It is believed that Venus maybe did have oceans like the Earth does, but these evaporated because it was too close to the sun, and that's the reason for the very thick clouds. Although the thick clouds are also made not just out of water, but carbon dioxide, and there's actually a mile thick layer of sulfuric acid clouds. It makes it very difficult to land a spacecraft on the planet, as you have to travel through this. Sorry? Okay, I'm back. Uh, because this is our first attempt, I want to make certain that we're recording everything. First off, if you're viewing from outside of Georgia, we'd love to get an email tonight. You can find my email address on our website, which is astronomy.godtech.edu. I'm jim.sowell@physics.godtech.edu. We are using tonight the 11-inch Celestron, and our camera is
Canon 5D Mark II.
a Canon
5D Mark II.
5D Mark II. We're using a laptop. We're actually sitting outside on the roof as we're watching and waiting for the moon to appear from behind the AT&T building. We had to pick a location so we could see Venus, which is way off toward the west, and the moon, which is way off toward the east. We do want comments from you. We want to make this an excellent event. We want to do this more often, probably when the moon is at first quarter instead of when it's full, but this is the way we scheduled it for this year. In fact, I'm seriously considering this might be a way to help K through 12 education here in Georgia this coming year. We could do broadcasts like this and arrange it with particular counties or with the entire state, and the children would be able to see it from their homes. They would not have to congregate at the school in the evening or anything especially like that. So we want to make certain that this will work, and we'd love to hear from you. So literally, I think we have about a minute or two where we can really see the AT&T building, and we're just expecting the moon to pop out. So we're going to leave it on Venus for just another minute or two. There might be someone else who is just now joining us, but I'm pretty certain that within 5 minutes we are going to be on the moon, and it is gorgeous. It was a nice orange color when we saw it come up. And but I also wanted to tell you, if you do have a little bit darker sky, there's some other nice constellations out. As I had mentioned, the winter constellations are near Venus in the west. The bright star to the left of Venus is Sirius, the dog star. You should be able to see some of Orion. If you look straight overhead, it's not as bright, but Leo the lion is straight overhead. It looks kind of like a cat sitting on the floor. And if you turn and look toward the north so that Venus is to your left, look up high, the Big Dipper is upside down. Then off to the east, we have the bright star Arcturus. Okay, I can see the edge of the moon coming off. So we're going to take a minute to slew the telescope. We will probably be back in less than 2 minutes. So we'll just need to take care of moving the telescope. And I think you're going to really enjoy this view because you're going to see both the building and the moon. And we're back. Again, this is broadcast from the Georgia Tech Observatory. This is a live streamed view of the full moon. This is May 7th, 2020. It's around 9 o'clock-ish. And John Wallum and Jim Sowell were here having a great time and leading you through this view. So this is the full moon, and I wanted you to see it, and I'm going to give you a diagram now so that you can see a few of the areas we want to highlight. And so this is an old drawing, and we've given you a few names of some craters and some maria. And John, do you think you could rotate the camera to meet up with us? So we're going to try to get the camera in this diagram to align. So I want you to, we're going to look at a couple of the dark regions. Galileo, when he first started looking at the moon, and he was the first with the telescope, thought that those were smooth areas due to water. John, that's excellent. And so these were called seas, and actually the large one on the left is so large they refer to it as an ocean. These maria, the Latin name, are made out of basalt. That rock is the kind of rock at the bottom of our oceans, the tectonic oceanic plates. And most of the maria on the moon are about 3 billion to 4 billion years old. The moon itself is about 4.5 billion years old. So they're not the oldest features. They've smoothed out some of the cratered regions. But we're going to look at some of the larger craters, which are actually relatively new. And I think we're about ready to go to that. So we're going to go back to the image of the moon, and I would like to go, you think we could get up here to the Sea of Serenity or Sea of Tranquility? So one of these areas, okay? Actually the bottom, whoa. Okay, that's good, right there. So this is actually a view of the Sea of Tranquility, and at the very bottom you can see a little bit of a bright speck that is very close to where the Apollo 11 astronauts landed. Now if we move up slowly, literally move the view the other way, sorry, that way. Okay, we get near the top, that's where the Apollo 17 astronauts landed. Let's continue to zoom in just a little bit, if we can go any further. So again, okay, so let's head over to this one. Okay, so we're going to move over to another one called the Sea of Serenity, which is the one up a little bit. And again, these regions are smooth because most of the craters on the moon were made about 4 billion years ago. There seemed to have been a time of heavy bombardment, and then large projectiles hit the moon, causing these very big, and you can see there were like craters, and over millions, in fact tens, hundreds of millions of years, lava seeped up from underneath and filled in and smoothed out these regions. But since that time, there have been a few additional large craters created. And so we're now going to head toward, go ahead, so this view. This view is of the crater Copernicus, and off to the left is Kepler. Okay, and what's neat about these craters, and by the way, so the big one, Copernicus, it's about 60 miles in diameter. Okay, so you know it would easily fit between Chattanooga and Atlanta, and Kepler off to the left is about 20 miles in diameter, so it would fit inside the perimeter. But you can see emanating, especially from Copernicus, the one on the right, there are white streaks. In the solar system, if you see a whitish color, even though it's for different reasons, it always ends up indicating youth. In fact, that's a nice view. Let's go to that one. So we've zoomed out a little bit, and you can see these fingers emanating away from the crater. These are referred to as rays, and they're easy to see because they're white on top of the dark maria. Remember, the moon has no atmosphere. So when there was a bombardment, when the creator was created and material was kicked out, that material was underneath the ground, so it had not been darkened by the sun, and it was blown out and flowed and created this radial pattern pointing away from the craters. You only see this with large craters, and they have to be relatively new because, in fact, these craters are about 100 million years old. They're a lot younger than the Maria. So we're going to go down to another one. We're going to go down to an even larger one called Tycho, and if the diagram, it's that one down there. The diagram, it was way down toward the south. So we're getting zoomed into it, and there it is. And so here's another one. Now this one is actually not on one of the Maria. It's out in an area where there are a lot of other craters. But even so, because of its youth and its size and the amount of energy released in the impact, the fingers, the rays, emanate away from it. If you're doing geology of the moon, there's only about 6 types of items. There are craters, Maria, the rays, and some valleys and cracks. It's a much simpler world to deal with than it is for the Earth. So actually, let's go back to, okay, we're looking for some rugged area. That's good, right there. So we're going to now move, we have the ability to jump around. We're off to the right edge. It's near the edges that you can see more ruggedness. In the future, when we do these online broadcasts, and often during our public nights, it was usually a first quarter moon. You're only seeing half the moon, but you can see much more ruggedness. With a full moon, you can certainly see more objects, but it's a little bit harder to see other craters. We've just now moved to another region. You can see they're very oblique as we're looking near the edge. And again, you can see, if you look at the edge, it's blurring just a little bit. We've got a gorgeous night tonight. The atmosphere is very calm, and it is a great night to go out and do a little bit of astronomy. So we're going to, I'd love to, it's the north area up here, there's this dark, which is barely, it's cut off up there. So I'm pointing out to John another feature on the moon I thought we would show you. And this is, we started with the Sea of Tranquility and then the Sea of Serenity. We're going to go over to a very large Maria called Ocean of Storms. And up near the top of it, there's a filled-in crater, and then there's also a very dark crater. Keep going. There, that's what I'm trying to center on. Okay? And actually keep that little section too. Okay? So, go to that. All right, so this is the topmost of the large dark Maria called Oceanus Procellarum, called the Ocean of Storms is how you would translate it. To the left, you can see a partially filled in Maria. This is Sinus Iridium, and there's a lot of neat features there. But almost straight up in this view is a dark crater right on the edge, and that one's named after Plato. You notice that the largest craters are named after some very famous astronomers and philosophers. As when the first features were being named, they were being honored. But if you actually look below it, so it's very dark, you see some white on top of the Maria. Those are some of the few mountains on the Maria sticking up, and they don't have the same composition as the basaltic Maria. Above Plato, there are some less well-defined Maria. There are about 20 Maria, but we see some of them very slanted, and so they don't jump out at us quite as much. Let's zoom back and let's just enjoy the view of the moon again. Okay, so the moon, let me just give you a couple of features or a little couple of details. So if you took this full extent of the moon and you laid it on the United States, the right edge would just barely touch the Atlantic Ocean and the left edge just barely touch the Pacific. So it's about the size of the continental United States. So as you begin to look at these various features, you can just think of the United States laying across it, and you'd have a good idea of the particular sizes. You can see in this view, there's Tycho down at the bottom. You You see how far the rays are emanating away from it. Variety of features. The Maria, a variety of them, very jumbled. I've had a chance now to look up at the moon, and the moon is heading toward the Bank
of America.
Bank of America? Bank of America building, the one I refer to as the Pencil building. So in probably 10 minutes, it's going to actually be behind the grill structure. You know, if you want to take a moment and, you know, go outside, you can see the moon right now, just exactly like we're seeing. And again, gorgeous night. There's very little atmospheric turbulence and shaking. And what do you think we could do now? Or should we go exploring again? Why don't we do that? Let's go exploring, okay? See what we can find.
I don't know where we are.
Go to an edge. Just keep going till you get to an edge. There you go. So we're right over here. Okay. So we're going to get off the script and we're just going to go exploring. So again, we're going to try to hug the edge of the moon. That's where you're going to see the most craters. Okay. So why don't we just kind of go around? Can we do that? We can do it. Well, or can we do it while you're? You can't. Okay. All right. So we're kind of going clockwise. We're going to go around. I think we looked at this area before. This is pretty neat, with many craters, and the moon is covered with lots of craters. In a full moon phase, it's difficult to see craters because the sun, earth, and moon are rather aligned, and it's difficult to see shadows. When we look at a first quarter moon, then we make a right angle, and the craters and mountains cast shadows, and we're able to see a variety of the ruggedness. I went back to this picture, the big crater right on the edge. You can see there's a mountain in the center. This occurs from the impact with many of the larger craters. It's almost like a little rebound effect, so that a mountain gets created. It doesn't happen with the smaller craters. Okay, you want to keep heading around?
We are at the bottom.
Right, head toward the bottom.
We're already there, is what I'm saying.
No, we'll keep going. Let's go around the bend. Now we're back. This is Tico. Okay, we'll get over to the left, and so we begin to see some more of the Maria. By the way, the Maria are not found on the far side of the moon. Now the moon keeps a face always toward the Earth. It's tidally locked. The Earth has stopped it from spinning any faster than its orbit. But the Maria are only found on the side that faces the Earth. We think it has to do with an aspect of heating by the Earth and the thickness of the crust of the moon being thicker on the far side and thinner on this side. We'll keep moving around. We're on the left edge. Good. Again, anywhere that you see white on the moon, all these little specks, these are going to be slightly younger areas, the youngest areas. The Maria would be intermediate in age, and then the rugged, large cratered areas would be the oldest. That's, I believe, Kepler that we're seeing, age of Kepler, with some of the rays. Keep going. Good. So how are we doing? Let's keep going. And again, many variety of rays. Here, a variety of Maria very close together. Okay. I think I'm about finished. I want to just leave a view. So we're going to stay up for, 5 more minutes or so and let you just enjoy the view. We'll cycle through them. If I think of something else to add, I will. Again, thank you for joining us. Again, this was our inaugural attempt, May 7th, 2020, from the Georgia Tech Observatory. We look forward to doing this many more times. We hope hope you have enjoyed the evening too. Thank you very much. thank you for joining us on our inaugural online streaming from the Georgia Tech Observatory. Again, this is a view of the full moon. John and I want to thank you for sharing a bit of your evening with us. We hope you always have clear skies and you're always looking up. Thank you again. Have a great night.